Okay, so how did you get on in the fitness app Body Statistics program? Now, the idea for this program is to simply create a report that showcases an individual's BMI based on their personal information. It should showcase their BMR, so the amount of calories that they burn whilst at rest in a day. It should also take into account an individual's activity level, which then helps us calculate and estimate how many calories that individual will burn in a day. The next part of the program should then ask what the target weight of the individual is and in how many weeks they would like to achieve that goal. And the final part of the report should simply tell the user how many calories they need to consume, which could either be a deficit or a surplus based on the estimated amount of calories they burn in a day, and then should give them the overall daily calorie intake they should consume in order to achieve their weight goal. So there's quite a lot to do here, but what this application will allow us to focus a little bit more on is calculations. How can we perform calculations in functions and return them accordingly? So let's dive straight in and tackle the tasks individually. First of all, I'm going to have a little import section that will enable us to clear the output. So from ipython.display, we can import the function clear_output. And this will do for the import section. And this will just allow us to make our report a little bit cleaner at the end. We can then move on to the fitness app logic and tackle task 1. We're first of all asked to create a function that can calculate a person's BMI. Now the BMI formula is already provided to you, which is weight in kilograms divided by their height squared, where height is in meters. So we'll first of all create a function which we know is done by putting the def keyword, and we'll call this function BMI. We can then open parentheses. Now the BMI formula is weight divided by height. So for this function, I'm always going to expect two pieces of information to be fed into it. For this reason, I'm going to include two parameters in the function header, one being height and one being weight. After I've included these two parameters, I can put a colon. Now we can simply convert the formula above into a Python calculation. So we'll create a variable called BMI_calc, and then we're going to set that equal to weight divided by, and in brackets I'm going to put height, and the way we can square height is by putting two asterisk symbols and then 2. Now seeing as we want to return the BMI from this function, we're then going to return BMI_calc, but what we'll do as well is we're going to wrap the BMI calc in a round function and pass in 2 as the second argument, which tells us how many decimal places we'd like the BMI calculation to be rounded to. So let's now test the function to see if we obtain a BMI as expected. So if we call upon BMI and in the parentheses we pass in first of all the height parameter, so let's say there is someone who is 1.7 meters, and as the second argument we pass in the weight in kilograms, so let's suppose that that person is 70 kg, you can see that when we run this function, we obtain a result of 24.22, and our BMI has been returned to 2 decimal places just like we asked. So this seems to be working as expected. Great, so moving on to task 2. We're then asked to create a function that can output a person's BMI rating. Now I've summarised the BMI ratings underneath for you to make it easier for you to reference. But in order to do this, we first of all need to create a function, so we'll put the keyword def, and for the function name, I'm going to call this BMI_rating. Now seeing as this function is going to be comparing the BMI value of the individual to the values listed above, I'm going to have this function take in one parameter, which will be the BMI value of the individual. So I'll put BMI inside the parentheses, and then I can close the function header with a colon. Inside the BMI_rating function, I can then simply use conditional statements to check BMI against the values above. So I can put if BMI is less than 18.5, then we want to return the string underweight. Elif BMI is greater than or equal to 18.5, and BMI is less than or equal to 24.9, then we will return healthy. If BMI is greater than or equal to 25, and the BMI is less than or equal to 29.9, we will return overweight. Else if their BMI is greater than 30, it will return obese. So for the final condition of our conditional statement, we can simply put else, then return obese. So let's test this function to see if it works accordingly. Let's call upon BMI underscore rating, and inside the parentheses, we'll pass in a BMI of 24, which we know we would expect to obtain a value healthy. When I run this code, you can see that we return healthy. If I call the function again, but this time inside parentheses, put 18, you can see that we return underweight. So our BMI underscore rating function seems to be working as we would expect. Great, so that's 2 tasks complete and 2 functions that we'll feel comfortable calling upon later in our code. So let's move on to the third task. We now have to create a function that can calculate a person's BMR, so their basal metabolic rate. And the way this is done is by utilizing the formulas that are presented on screen. So we have a formula for men, and we have a BMR formula for women. W in the formula stands for weight, where weight is in kilograms. H in the formula stands for height, where the height is in centimeters. And A in the formula stands for age, where the age is in years. So this should be relatively straightforward, bearing in mind we've been given the formula on screen. So let's define a function called BMR, and seeing as the formulas reference height, weight, and age, as well as there being a different formula for men and women, inside the parentheses I'm going to include 4 parameters. The first one will be height, the second one will be weight, the third parameter will be referenced to age, and the fourth will be referenced to sex, i.e. either men or women. I can then put a colon after the function header. Now inside the body of the BMR function, we can now write the formula. But the first thing we want to do is obviously ascertain whether the person that is using this application is either a male or a female. And this will come through as an argument inside the parameter labeled sex. So if we put if sex and assume that this is going to be a string, if we access the first letter of that string that they pass in, therefore putting square brackets and a 0, if we then put dot lower and access that letter in lowercase, we would expect this to be either male or female. So we would expect them to have written M if they are a male. So we can put dot lower with parentheses is equal to M in lowercase. Then we want the formula that pertains to men. So we can put BMR underscore calc is equal to, then we can simply write out the formula. So we can put in brackets 10 multiplied by weight. We can then plus, and we can then open up parentheses and put 6.25 times height. Now be careful here because height is actually in centimeters with respect to this formula. And seeing as height in the BMI calculation is presented in meters, we will need to multiply this by 100 if we intend to use the same variable for both calculations. So we'll also put height times 100, and then we can close parentheses. We can then minus 5 times age in brackets, and then for the men formula, we then add 5 to the end. We can then put else, and then we can write out the respective formula for women. So we can put BMR underscore calc equals 10 times weight, so the same as the men formula. We can then plus 6.25 times height times 100, which is also the same as the men formula. We can then minus 5 times age, same as the men formula. And this time the only difference is that we minus 161 from the result. So with the 2 formula now written out, we now need to state what we want to return from this function. So we're going to put the keyword return, and we want to return the BMR underscore calc. So we're going to return BMR underscore calc We'll once again place this inside the round function and we'll put 0 as the second argument. And then I'm going to change the data type to be an int. But this is just preference. You can use any suitable data type you want. So let's now test our BMR function. So we'll first of all put BMR, and then inside the parentheses, we need to put the respective arguments. So for height, we know this is going to be in meters based on the BMI function we've written above. So this can be the same person, let's say 1.7 meters tall. The person is 70 kg. We'll say that the person's age is 30. And we'll say that the person's sex is male, but we're going to expect this to come through as a string, so we can put in single quotes the word male. When I run this function, you can see that we get 1618 returned to the screen. So what this would mean is that for this specific person, the expectation is that if they were to rest for the whole day, the chemical reactions inside their body would actually burn 1618 calories per day. So if they are consuming less than that amount, you would expect them to be losing weight every day. But we'll pause on that for now and we'll move on to the fourth task. The fourth task asks us to create a function that uses the Harris-Benedict equation to determine an individual's total daily energy expenditure. Now you can see here that depending on how active you are in a day, you need to multiply the BMR that was calculated above by a specific factor. Now if the person does little or no exercise, we multiply the BMR by 1.2, we multiply by 1.375 if they are lightly active, 1.55 if they're moderately active, 1.725 if they are very active, and 1.9 if they are extra active, maybe going to the gym twice a day. So let's code up this function. We can first of all put the keyword def, and then I'm going to label this function calories_burn. Inside the parentheses, we know that we're going to be taking in the BMR that was calculated above. So I'm going to have one parameter and I'm going to call this BMR. I can then put a colon. Now the first thing I'm going to do is just create a variable for each of the conditions above and then have the respective formula. So I'm going to create a variable called sedentary and then I'm going to set that equal to BMR multiplied by 1.2. And I'm going to round this to 0 decimal places. I can then copy and paste this formula 4 more times, and the second formula I will change the variable to be called light, and then we can change the factor from 1.2 to 1.375. We can change the third formula's variable name to moderate, and then we can change the 1.2 to 1.55. We can change the fourth formula's variable name to very_active, and then we can change the 1.2 to be 1.725, and the final formula we'll call the variable extra_active, and then we will change the factor to be 1.9. So we now know, depending on the user's activity levels, we get a different estimate for the amount of calories that they'll burn in a day depending on how active they are. Now the results of each of these calculations would be quite useful to reference at any one time, because maybe the person moves from a lightly active lifestyle to an extra active lifestyle the following day. So for me personally, I'm thinking the best way to store this data would be to utilize a dictionary data structure. So I'm going to create a variable called calorie_burn, and then I'm going to set this equal to an empty dictionary. Inside of this dictionary, I'm going to create keys which are numeric values. So I'm going to put 1 as the key name, and then I'm going to put a colon, and the first value that I want associated with the key name 1 is the value that's stored in the variable called sedentary. I can then put a comma, and then the second key, which we'll label as 2, will have a value referenced as light, which is calculated above. For the third key, we will have moderate associated with it. For the fourth key, we'll have very_active. And for the fifth key, we'll have extra_active. So if I were to now reference a specific key associated with calorie_burn, we will then get the respective amount of calories back from the function. Now the final thing I want to do is actually print to the screen how many calories they would need to give them more guidelines. So I'm also going to print some statements to the screen. So I'll first of all print a sentence that says, to maintain your weight, follow these daily calorie guidelines. And then I'll put a colon. On the next line, I'm going to print 1, which refers to the sedentary lifestyle, and then put a dot. I'm then going to put little to no exercise, and then a colon. I'm then going to put you need equals and then a set of curly braces. I'm then going to put k/cows, use the format method, and inside the format method, I'm going to put the variable sedentary. I'm then going to copy and paste this print statement for a second time, and I'm going to change 1 to 2. I'm going to put light exercise brackets 1 to 3 days per week, and then a colon. You need curly braces, kcals, and then the format method will have an argument referring to the variable light. I'll then copy and paste this, and we can then print 3 dot, and then moderate exercise brackets 3 to 5 days per week, you need, and then in the format method, we're going to put the variable moderate. And to speed things up a little, we're going to have the 4th referring to heavy exercise 6 to 7 days per week, and then we'll place very active in the format method. And then the final one will be 5, which is very heavy exercise brackets twice per day. You need X amount of calories, and the X amount will refer to the extra_active variable. So therefore this will always get printed to the screen, but what will be quite nice to use elsewhere in our code or refer to is that dictionary that we created above. So the final thing I'm going to do for this function is return the calorie_burn variable, which we know stores a dictionary object. So let's just check to see that this calories_burn function is working as expected. If we call calories_burn and we put 1618, which was calculated in our BMR function above, you can see that we then get printed to the screen. Little to no exercise would need 1942 calories, light exercise would need 2225, 2508 for moderate, 2791 for heavy exercise, and 3074 calories would be required to maintain their weight if this person was exercising twice a day. You can then see underneath this print statement, we return the calorie_burn object, which is a dictionary stating for each activity level how many calories they would need. Great, so it's working as expected. Let's move on to task 5. In task 5, we're told, based on a target weight provided by the user and the timeline they would like to achieve their goal, determine the amount of daily calories they should consume. And in the paragraph below, we're told that 1 pound of fat would need a calorie deficit of 3,500 calories in order to lose it. So if you were to have 500 calories less than what was calculated above every day for 1 week, the expectation would be that you would lose 1 pound of fat. So let's see if we can create a function that deals with this target weight calculation. So we'll put def and we'll call this function target_weight. We can then put parentheses and a colon. Now to start with, in the body of the function, I want to know what the difference is between their target weight in kilograms and their current weight in kilograms is. So we'll put delta_kg as the variable name, and then we'll set this equal to weight_goal minus weight. And that's going to give us the difference in weight that they're looking to obtain. So it could be less than their current weight, or it could be more. So we could end up with a negative value here or a positive value. Now, if the delta_kg variable ends up being a negative value, we know that they will need a calorie deficit because they need to consume less calories in order to lose weight. So we can put if delta_kg is less than 0, then a variable called deficit_surplus will equal the string deficit. and we can include this in a sentence in the report later on. Else, we can stipulate that the deficit underscore surplus variable should then hold the string surplus. And this will simply be slotted into the report when we get to it. Next comes the interesting part where we need to use some calculations in order to work out the amount of calories that this person would need in a day in order to meet their weight goal. So seeing as we've been told that 1 pound of fat is equal to 3,500 calories, I want to convert the delta from kg to pounds. So I'm going to create a variable called delta underscore pounds, and there are 2.2 pounds in every kg. So what we can do is we can multiply the delta underscore kg variable that we calculated above by 2.2. And because the person may want to lose weight or gain weight, I'm actually just going to wrap this in a function called abs, which will make this a positive number. Now with this information, I can now work out the calorie deficit or surplus that this person would need. So I can put delta underscore calories, and this will simply be a multiplication of the delta underscore pounds that we've created above, multiplied by 3,500. So for every pound, we multiply by 3,500, and this will give us the total amount of calories that they'd need to be in deficit by or surplus, depending on what their weight goal was. Great, so we've got the delta in pounds, and we've also converted that to calories. Another nice piece of information to know would be how many pounds they are looking to lose or gain per day. So we'll create a variable called pounds per day, and we'll set this equal to delta underscore pounds, which we know is the total amount, and then we're going to multiply this by the amount of weeks they want to obtain this goal in, and we'll simply write this out as weeks with the expectation of creating this later down in our code, and then we'll multiply this by 7. So let's say the person wanted to achieve this weight loss over 7 weeks. We'd multiply 7 by 7 days, which gives us 49 days. If we divide the delta underscore pounds by 49, this would tell us how many pounds they're looking to burn per day. Okay, great. I now want to calculate how many calories per day the user would need to either be in deficit by or surplus. So the first thing I'm going to do is bifurcate the two. I'm going to put if deficit underscore surplus variable, which we created above, equals deficit, then I want the calories per day variable to equal, and the calculation will be the delta underscore calories that we calculated above, which is the entire amount of calories they would need to lose or gain to meet their weight goal, and then I can divide this by weeks multiplied by 7. Now, because we have a condition checking that deficit underscore surplus equals deficit, this variable will be for those who want to lose weight. So I'm going to multiply this by -1, which will help us later on when working out the total amount of calories that this person will need in a given day. I'm then going to wrap this entire formula in a round function, and I'm going to have the second parameter set to the value 0. I can then put else, and then I'm simply going to copy and paste the formula, but this time I'll delete the multiplied by -1, so we're left with a positive number, and this will relate to those who want to gain weight. Now, in a similar way to our calories underscore burn function, I'm going to return a dictionary that enables us to reference different variables from this function. So I'm going to return a dictionary, and the first variable will have a key of delta underscore kg, which will have a value referring to the delta underscore kg variable. We'll also have deficit underscore surplus as a key, and this value will be the deficit underscore surplus variable. We'll do the same for the delta underscore pounds, the delta underscore calories. The pounds per day could be quite useful, and we'll also store the calories per day. And the calories per day will be very useful in working out how many calories each individual would need to consume in order to meet their weight goal. Okay, great. So let's pause on this for now, and we'll move on to the final task before we get onto the report. And the final task asks us to create a function that checks to see if a user wants to use the app again. So we've seen this before, so let's quickly rattle through this. We'll create a function called use underscore again. We can then put a variable called replay, and we'll set this equal to the input function, and we'll state, would you like to use this app again? And then in brackets we can put y/n followed by a colon. We can then put a conditional statement that checks to see if replay.lower is equal to y. In other words, they want to use it again. Then we'll return the boolean true. Else we will return false. Okay, so we're now at the part where we need to generate an entire body statistics report for individuals who use the app. And this can be for anybody. So let's get straight in to generating the report. We're first of all going to set a while loop, so we'll put while true, which we know will continue to run until we break out of this loop, which will be done by checking to see if they want to use the app again. Inside the main body of this while loop, we need to collect some information that will then feed into our respective functions. So we'll first of all collect their name, so we'll create a variable called name, and we'll set this equal to an input function asking what is your name. We'll then have a second variable called age, which will be equal to the input function labeled what is your age. But for this variable, because we know we want to consume a number, and by default the input function returns a string, we're also going to wrap an int function around this. The third variable we're going to call sex, and we're going to have that equal to an input, which is what is your sex? Question mark, and then in brackets we'll put male or female to provide the users some form of guidance as to what we're expecting in this input box. We need their height, so we'll create a variable called height, and we'll set this equal to an input function asking what is your height in meters? Question mark. Because this could have decimal figures, we're going to also then wrap this in a float function, which will convert the type from a string to a float. And finally, we're going to create a variable called weight, and we'll set this equal to float, brackets, then the input function, brackets, what is your weight in kilograms, to give them some guidance as to what we're expecting. Okay, great. So with this input provided from the user, we should now be able to complete the first part of the report. So let's first of all tackle the BMI section. So we'll create a variable called BMI underscore result, and we'll simply set this equal to a call on the BMI function. So we'll put BMI, and because we've already defined the height and weight variables above, we can simply pass these in as arguments to the parameters that were defined when we defined the function. So that should create the BMI for this person. Let's do the same for the BMR result. So we'll create a variable called BMR underscore result, and we'll set this equal to BMR function, and we know that we've got 4 parameters called height, weight, age, and sex. These have all been captured in the input variables above, so we can simply write them out. So we can have height, comma, weight, comma, age, and then the 4th argument is sex. Now the important thing here is to ensure that you get the order of the parameters correct. If you don't, then the formula will be calculated incorrectly. Now after we've collected this information, I'm just going to put clear underscore output to make sure we have a clean slate. And then I'm going to print out the report. So I'm first of all going to print a multi-line string, so I can put 3 dashes, and then I'm going to put hello and then curly braces with an exclamation mark. Here is your fitness report. You are a curly braces, year-old curly braces, full stop. You are curly braces meters tall and weigh curly braces kg. I can then put here are your body statistics with a colon, and then I can use the format method and simply slot in the correct variables in place of the curly braces. So we know we want name as the first set, you are a age as the second, year old, sex as the third, you are height meters tall, and weigh weight kilograms. So straight away the user will be presented with information that the user has put in as a bit of feedback. If they haven't got it right, they can obviously use the app again, but this will just give them confirmation that what they've written is correct. We'll then print some dashes just to separate the report for clarity, and then I'm going to print your BMI is curly braces. I'm then going to use the format method and slot in the variable BMI underscore result. I'm then going to print an empty string just to give us some space in between the lines, and then I'm going to print out the BMI rating. So we can print out, based on your BMI, you are classified as, and then curly braces. We can then use the format method, and inside the format method, we need to work out what the BMI rating is. So I can simply call upon the BMI rating function that we defined above. So we can put BMI underscore rating, and we know that the BMI rating function takes in one argument, which refers to the BMI. So inside the parentheses of the BMI rating function, we can slot in the BMI, which we know we have stored in a variable called BMI underscore result. So we'll put BMI underscore result. On the next line, let's separate this from the BMR section, so we'll put some more dashes. I can then print out your BMR is curly braces. And then I can use the format method and simply slot in the variable which calculates BMR, and it's stored in BMR underscore result. I will then print out an empty string. Now at this point it would be quite nice to print to the screen how many calories they are expected to burn based on their activity level. And this is stored in the calories underscore burn function. So we'll simply create a variable called calorie underscore consumption, and we'll set this equal to a call on the calories underscore burn function, and inside the parentheses we need to pass in the BMR so we can put BMR underscore result. So at this point we would then be expected to be presented with the sentences telling them how many calories they need to maintain their weight. After this we'll print out another empty string, and then I need some information from the user to tell me what category they're in, so I can work out what they will need to consume when we look at their target weight goals. So I'll create a variable called activity underscore level, and I'm going to set this equal to the input function, asking which activity level are you, brackets 1 to 5, and this should give them plenty of information because what will be printed to the screen will have a number next to it so they can simply align their activity levels. And because they're providing a number, I'm then going to wrap this in the int function. With this information collected, I'm then going to print some dashes to separate this next section in the report. What we now need to ascertain is what the weight goal is of the individual. So I'll set a variable called weight underscore goal, and I'm going to set this equal to an input function asking for the weight. So we'll put what is your weight goal, brackets kg, question mark, and we'll wrap this in the int function because the expectation is that they will provide an integer. We will then set a variable called weeks and set this equal to the input function asking in how many weeks would you like to achieve this goal? And then we will put a question mark. We would also expect this to come through as an integer value, so we'll also wrap this in the int function to convert the input from a string to an integer. I then want to create an object which calls upon the target underscore weight function, which we know returns a dictionary and provides us different bits of information. So we'll create a variable called calorie underscore info, and inside this variable we're going to call upon the target underscore weight function, which we know returns a dictionary object with different bits of information in it. I can then print some more dashes, and then the final print statement that I'm going to put under this line is the sentence that everybody has been waiting for. We will print on a multi-line string, to achieve a target weight of curly braces kg in curly braces weeks, comma, you will need to consume, and then on a new line we can put a curly braces of curly braces calories. And the first set of curly braces on this line will refer to either a deficit or a surplus, and the second will refer to the number of calories they need to be in deficit or in surplus. Full stop. This means your daily calorie intake should, and then on a new line, be curly braces calories, exclamation mark. Good luck in achieving your weight goal, exclamation mark. And then we can use the format method and simply slot in the right variables where the curly braces are. So for the first set of curly braces, we know we need to use the weight underscore goal variable that we collected above. The second set of curly braces will be in reference to the variable weeks. The third set of curly braces will be either deficit or surplus, and we know that we've stored that information in the dictionary that comes from the target underscore weight function, which we're storing in a variable called calorie underscore info. So I can put calorie underscore info, and then I can access the value with the key deficit underscore surplus. I can then put a comma. The fourth set of curly braces will be in reference to the calories that they need to be in deficit or surplus by. So we can once again call upon the calorie underscore info object, which is that dictionary object, and we can collect the value that's in reference to the key calories underscore per underscore day. And because we don't want this to have a negative value, we'll also wrap this in the abs function. Now the final set of curly braces is the amount of calories that should be consumed in the day. So we need to do a small calculation within the format method. So we can put calorie underscore consumption, which is the variable storing the dictionary of estimated calories that are required to maintain the body weight, which we know we've calculated in the calories underscore burn function. So we can put calorie underscore consumption, and based on the activity level that they set in the variable above, which we asked for earlier, inside square brackets we can put activity level. So if the user put in 2, which makes them lightly active, that 2 will be associated with an amount of calories that we know that they should be consuming in a day to maintain their weight. Now on top of this value, we need to then add the amount of calories per day that they either need to be in surplus or deficit by. So if we plus then the calorie underscore info and access the calories per day key, we will now be able to see how many calories per day that user should be consuming in order to meet their weight goal in their specified time frame. The final thing we will do is print a set of dashes to close the report. And obviously this is a while loop, so we want to make sure that we can break out when the user wants to. So we'll put if not use underscore again, then we will break from the while loop. After this, we will clear underscore output in case they do use the report again and want to generate a new report. And at this point, touch wood, when we run this report, we will be able to see exactly how many calories we need to consume in a given time frame per day in order to meet our weight goal. So let's give it a go. So we'll first of all go up to kernel and click on restart and run all. When the code has run, you can see that the while loop's first question is asking us, what is your name? So for this example, I'm going to assume my name is Simon. Great. What is your age? Well, let's say Simon is 30 years old. Okay, what is your sex, male or female? Simon is male. Okay, what is your height in meters? Let's suppose Simon is 1.8 meters tall. Great. Okay, what is your weight in kilograms? Let's assume Simon weighs 80 kg. Okay, great. We're then presented with something to the screen. You can see here it says, hello Simon, here is your fitness report. You are a 30-year-old male, you are 1.8 meters tall and weigh 80 kg. Here are your body statistics. Your BMI is 24.69. And based on your BMI, you are classified as healthy. Well done, Simon. Your BMR is 1,780. And then we're presented with some information which says, to maintain your weight, follow these daily calorie guidelines. Okay, fantastic. So we've got 5 different guidelines depending on our activity level. Now we're also asked, which activity level are you from 1 to 5? So I'm going to assume that Simon is moderately active and he goes to the gym 3 to 5 days per week. So we'll put in the value 3. With that information provided, we're then asked another question. It says, what is your weight goal? Now Simon feels like he's slightly too heavy and he would like to get down to 78 kg. So let's put 78. Now with this in mind, we know that he would need to be in a deficit in order to achieve any goal, so let's hope that our report picks up on this information. After providing our weight goal, the application asks us in how many weeks would you like to achieve this goal. Now let's suppose that Simon wants to achieve this goal over 6 weeks. He's going on holiday in the summer and it's 6 weeks away. Okay, so with a 6-week goal in mind, we can see that we're presented with the final sentence that says, to achieve a target weight of 78 kg in 6 weeks, you will need to consume a deficit, which we know would be correct, of 367 calories. This means your daily calorie intake should be 2,392 calories. Good luck in achieving your weight goal. And if we look at what Simon needs to maintain his weight at moderate activity levels, it's 2759. So if we were to do 2759 minus the deficit of 367, we do indeed get 2,392 as the expected daily calorie intake. And if he consumed this every single day for 6 weeks, you would expect him to be able to meet his 78 kg body weight goal. Would you like to use this app again? Now, in the interest of time, this video has gone on for some time. I'm going to put N and then we close out of the application. Now, you can use this application for anybody. It's a rough estimate of what you would need to consume if you did have a body weight goal in mind. But that aside, what you've learnt here whilst being distracted with the problem of trying to create a report that helps us determine the amount of calories we need a day is utilize Python code to make things so easy to implement. We've utilized functions, calculations in functions, conditional statements. We've started to use more parameters and arguments in our functions, feeding different objects through to those functions, and we've created a very nice report which would help anybody in achieving their fitness goals. I hope you enjoyed this project and you've reinforced the learning of topics that we picked up earlier. We're on a roll, so let's keep going. I'll see you in the next project.